welcome everyone. Thank you for joining our session today. My name is Dan Taylor, and I'm a product architect working on the Azure AI Foundry.
I'm Rob Chambers. I'm a technical advisor working on the same team with Dan.
And despite what our titles say, both Rob and I are actually developers. And you've seen a lot of really cool stuff today, and what we want to show you in this talk today is a more practical, hands-on guide of what it looks like to code some of these experiences so that you can build the future of AI. We're in the era of AI development. Every single application will be reinvented with AI, and new apps will be built where things weren't even possible before. And there's a lot of people building AI applications today and building with AI. There's going to be up to 1 billion applications, new applications built over the next 24 to 36 months. 70% of organizations are accelerating modernization and bringing AI into their existing applications. And 90% of developers are using AI in their tool set. How many people here are using AI in your tool set right now? That looks like about 90% as far as I can tell.
Nice.
Good on you. But the reality is that the conversion rate from building at proof of concept to getting to production is still pretty low. About 14% of applications make it. And 74% of organizations are still in the experimentation and planning phase. And of all the factors that hinder getting to Gen AI production, we're going to focus on the 41% of apps where they lack the developer skills and tools. And so what does it look like to build these applications? Well, here at Microsoft, we provide some of the world's most loved developer tools between Visual Studio, GitHub, and Copilot Studio. And we want to start off by showing you what it looks like from what one of our customers, ABB, has done to build their Copilot. Let's go ahead and watch the video.
At ABB, we provide technologies for manufacturing and industrial operations all over the world. The industries are going through a significant transformation. They have been challenged to be more productive, efficient, and more resilient. Our digital flagship product is GenX. It analyzes the functions such as asset, operational, and process performance, emissions, and energy savings. But one of the biggest challenges is pulling the data from the different source systems and contextualizing them in a platform approach. We chose Azure OpenAI Service because of its customization, safety, and dependability, and built GenX Copilot to help our customers ask a question in natural language and get the answers and make better decisions immediately. The customer might ask GenX Copilot, what is my industrial emission level today? It gives recommendation, reduce the cooling fan speed to reduce the energy consumption by 12%. Customers are seeing the value of AI. It's cutting the maintenance cost up to 30%, improving the asset reliability by 20%, reducing the carbon emissions by 15%, bringing the energy consumption down by 20%. By integrating Azure OpenAI with our domain expertise and technologies, we are solving some of the most complex problems in the industries.
All right, what I really love about the GenX Copilot that ABB has built is how polished that user experience is and how powerful it is, and the productivity that it unlocks for their customers. This seems like some pretty advanced stuff, though. So where do you start as a developer? Well, I want to kind of break it down to a few simple concepts, and then we'll build from there. So at a fundamental level, building with AI is you write some code that takes some data, it generates a response or a prompt. You send that prompt into a model, and you get a response out. You do something with the response, and you keep going, right? And so as you scale that up, what this looks like, it turns into having many different conversations with many different agents, with different pieces of code processing that data and extracting that information into that useful user experience that you saw in that video. And so the way we're writing code is changing. We're going from building deterministic applications to probabilistic applications with probabilistic outputs, from writing code to writing prompts, from building features to creating agents that do useful things, and from testing those deterministic outputs to evaluating them and scoring them on a scale from 1 to 5. And the things on the right aren't replacing the things on the left, but it's a new tool set that you need to integrate into your development processes. And so we have the Copilot and AI stack can help you do all of this. At the top, we have the Azure AI Foundry, which we'll be showing a lot today. which builds on top of your data and our AI infrastructure and integrates into the world's most loved developer tools. And so, as developers, we like to start small. And what does this process look like? What's the roadmap for building applications? Well, you take some data, and then first you prove that you can get something to work with a proof of concept. Then you get your application into development, and you're trying to get it to production quality. And then once you're in production, you're taking data from the actual production app, you're feeding it back into the development process so that you can continue to improve and optimize the user experience. And so, talking about building a proof of concept, we're going to go through those 3 phases today, but Rob is going to get us started off with what it looks like to build that proof of concept.
That's great. Thanks, Dan. Thanks for setting all that up. So, oops, sorry, too soon. What I'm going to do is I'm going to talk to you about how we're trying to meet you where you are with various choices at the different layers inside of the stack. So we're going to start off by, obviously, developers need IDEs or portals or their shells. Who here uses an IDE? How about a shell like Bash or PowerShell? All right, yeah, that's great. But what you need from us then is you need us to meet you in those locations at the right times. And so we're doing that by making sure we have the correct kinds of IDE extensions in the right shell, in the right IDEs, that we can meet you in the right places with CLIs in the shells that you've grown to love. At the same time, for that to work, we need to build that on top of a great set of documentation and repos that have all the samples that you need. And it's available in the language that you program in, not some other language that you don't program in. All of that then is fundamentally based on top of SDK client libraries and packages. And there's a lot of variation and choices there as well. And so we're going to go through those today. With that, I'm going to jump in and start showing some of the code. So you'll see me at the screen, my shell. In this section, we're going to talk about GitHub models. We're going to look at across the various IDEs, portals, and CLIs inside of shells. So we're going to start out by looking at the GitHub model collection at the marketplace. So if you go to GitHub/marketplace today, you'll find all of the models described. You can go and list through the different models to see all the different capabilities across providers. You can even filter those providers down. You can eventually select one of those and take it into a playground experience. You've probably seen some of these earlier today, but that you can ask it a question. Something simple like, how tall is the Willis Tower in Chicago? Press enter, text in, text out like Dan was talking about. We get a prediction back out. And this is really nice for developers, both because it's free. You can just use it right away. If you have a GitHub account, and everybody here has a GitHub account, right? Yes? Yeah. And so you can use it for free. You can use it simply. But it's not inside your IDE or it's not at your shell. So what you can do is you can come over here to the VS Code extension that's called the AI Toolkit. It has a way for you to see these same models. It actually has a few more models in it as well. But if I click on this and filter down to the things that are hosted by GitHub, I can then filter down on publishers to things like OpenAI. And then I can take that and make an entry over here on remote models and come into a playground experience as well. So in the same kind of way, I can play here, just experiment with it, change different aspects of it, the system prompt instructions or different parameters. I can even switch off to other models like the 𝗲3 model, run that remotely. I can even use the 𝗲 model running locally as well. So all of this gives it to you right here in this shell, or in this IDE. We're going to ship back to the experience here. GitHub has this new models extension to the GitHub CLI. And with that, too, you can list all of your models. There they all are. You can then do very simple things like checking out what a single prompt looks like. But because it's in a CLI, you can do neat things with that data in aspect. Anything that you can produce as data in, you can just pipe into the GitHub models extension and have it do something. So very simple example here is I'm going to look inside this command, which is helping me show what I'm going to be showing you. But maybe you don't understand what that looks like. So I'm going to give that to the GitHub models extension with GPT-4o Mini, ask it how it works. It's going to go through it very detailed and let me know what it is. So you can do that with anything you have very easily, data in, text out. So with that, I've shown you that you can use the GitHub models both at the portal, you can use them in VS Code, and you can also use them at the CLI inside the shell of your choice. So with that, we're going to go into the next section here. I showed you a CLI. That CLI is specific to GitHub. We also have a new CLI called the AI CLI, which is an open source repository. And to take a look at what that looks like, there's this documentation site, actually built mostly by AI itself, but it shows you how to install it. It works across various things like GitHub, Azure AI, OpenAI. You can use Onyx. Also frameworks like semantic kernel or doing things with speech, things like that. So we're going to come back to the shell window here. And you can take a look at the various things you can do. It's got built-in help, so you can either use the website to get the help, or you can do the help right here in the CLI at the shell. One of the things that's really neat to do here that's not available in the GitHub models extension yet is to do conversation inputs and outputs. So I'm going to do this. Tell me a joke. It'll tell me a joke. I exit, and I take a look at the conversation history. This is that conversation in, conversation out that we saw. So then I can take that and just modify it from output to input and say another. And it already has that context. So you can actually save that off and then reuse it in different ways once you have that set up. All right. Additionally, in addition to the chat history, there are these things called function calling. Who here uses function calling today? Ooh, much smaller number. You're all going to want to use this after this talk. So what you do, we're going to show it to you here in the CLI. We're also going to show you how to write the code. So you just run it like this. You can see that it looked at the directory. I asked it, like, what is in this directory? I can say, what is README trying to tell me? Be brief.
I love that the AI can overcome your typos, you know?
Exactly, standing on stage, right? So it actually described the various parts of what is in here and what we're going to try to do. So one of them, it tells us how we actually can build a sample application using JavaScript. Let's go ahead and do that. To do that, you can list a bunch of different samples that are built into the CLI across all kinds of scenarios. You can narrow it down to a particular language or a particular set of capabilities. But what we'll do is we're just going to focus here on creating one sample, this one. And then we're going to start installing stuff, pm install. While that's happening, we're going to go back to the book of AI and take a look at the code that's in there. So this is going to go through what code just got created. Function calling basically is you create a function, you actually create a schema that describes that function, then you can give it to the LLM and it can take advantage of using that. The rest of the program is simple. It just gets the connection inputs and information, goes off, shows you that you put the system message in. When the user asks something, you put the user message in, ... etc. So we're going to go back here and run it and see what it does. To do that, I'm going to use this thing called AI dev shell, which then populates all that stuff so there's no copy paste for you. And then I'm going to run it and ask it, what time is it? There you go. You can see that it called the function. It just knew to call the function because we described it to it. And that's another way to get data into the system. But how easy is it to make those functions? We saw that a little bit, but let's actually watch how very simple it is, especially when you have Copilot at your disposal. So what if I wanted to be able to see what the user's name was? Let's do function get username, return Rob Chambers. And then Copilot's actually going to predict the rest of it based on the context that's in the file. I think I typed like 12 characters in that whole thing.
I think you pressed tab 3 times.
I pressed tab 3 times. That's
Yeah.
true. I might not be counting that. So I come back here and run it again. Oops, sorry. Node main.js. And I say, what's my name? And now it knows my name. So what I've shown you here, oops, exit. What I've shown you here is how to get started with the AI CLI, the kinds of things you can do like chat history, and also how to use it to build a quick sample for you. All right, so we're going to go back over here, go to the next one. Now, once you've done that, this has all been done using GitHub models, but you can maybe take on even more capabilities and features by taking a look at the OpenAI Assistance API or AI search or speech input and output, things like that. So what we'll do is we're going to jump right into that. We've shown you a little bit about function calling. There are these things called assistants If you wanted to create an assistant using a bunch of files, you can just do this. It'll create the assistant, it'll create the vector store, it'll upload all the files, it just goes through it. It's going to take a little while. I'm not actually going to do that in front of you, but what I'll do is show you how it works once you've done it. What I did here is I pushed all the source code to this open source CLI up to it.
So you put the source code for your CLI
I did, the C# source code.
search.
I just put it right into the system. And then what I'll do is I'm going to take this question and paste that in. It's going to ask where in the source code does this happen. And it correctly identified it's in the chat command.cs file. And then I can ask it also when I'm using assistants, what are the key functions in that assistance helper class that actually that thing uses? And it goes through and tells me what all those were. This source file has, this collection of sources, about 450 source files. So very, very simple to do. Sorry, go back here. And I'm going to show you a little bit about AI search. Basically, you just go to this next tab over here. Oops, one more. I'm going to show you, you can initialize it, you can create a new search index. There's a lot of samples that Dan's going to go into about how to do that. So in time, we're going to skip past that. Last thing I'm going to show you is a little bit of stuff around what you can do with the speech capabilities that are in here. So with this, we've got input, we've got output. I'm going to show this, should come across the speakers.
Hello Ignite 2024.
That was pretty easy. If I wanted to see how I save that into a file, that's what this looks like. Now I've got a file, and if I wanted to figure out if I had a WAV file like that I just created, I can get the text back out of it. I can also translate it into multiple different languages. It's very, very easy to do. And all these things that I've shown you here are things that you can build your own source code to that are included in this experience. So you just pick one of these things, instance it on your disk, and then use it straight away with the same AI dev shell so you don't have to copy paste any keys or anything. Dan's got a better way to do these things without keys. He's going to show you in a little bit. So last one I'm going to show you here is the real-time API, which is very cool. You've probably seen a lot of demos about this today because it's amazing. 𝗦𝗲𝗀𝗀 had a fantastic one with the phone in the keynote today. We're going to look and see how that actually works. So again, you could build one directly from the CLI, but what I'm going to do is I'm going to use one that I've already created here. And I'm going to go back and do AI dev shell, populate all the environment, and then I'm going to do .NET run. Now, I've also integrated in the ability to turn speech on and off with the press of a key because we're in this big auditorium, and that might not be great if it's just open mic the whole time. It's also got a keyword spotting capability built into it, so I can interrupt it with a key and ask things, or I can use the keyword. So I'm going to show you the push to start talking. What's the date?
Today is November 19th, 2024.
Well, it came out on my computer. Hopefully some of you heard that. It's supposed to come out on the other one.
So some loud speakers, man.
I know. I tell you, I got to turn it up. But it does the function calling in the same kind of way, but it also has keyword spotting capability, so I can just use a keyword to activate it. Quincy, what's the date?
Sure, I'm here. What's on your mind?
What's the date?
What's up?
Yeah, these speakers, right? Hold on, one more time. Quincy, what's the date? There you go. Told me what the date was. OK, and behind the scenes, it had called that function. So we're going to go ahead and take a look at what that code looks like. Very simple. Basically, we give you everything you need. We've got capability examples to show you how to get audio from the right thing. In this example, this is a C# example using the in-audio package. We also show you how to do keyword integration to get the audio off of the keyword. These things that are in this directory here are basically the same as all of the other examples that are in the CLI, how to do function calling, et cetera. And if you wanted to go here and look at the custom functions, these are pretty cool. I made a new one here, which I can launch a URL. So I'm going to go back and show you what that looks like. Can you open the Bing homepage?
Sure, I'll open the LinkedIn homepage for you. I've opened the
Well, you know, LinkedIn, Bing, we have both of those. So, OK. Anyway, audio aside, there you go. That's how that all works. Dan?
Getting a couple slides.
So we saw how to actually use GitHub. We upgraded to use the capabilities of Azure. What else can we do?
Well, one thing, Rob, is that was a lot of stuff.
It was a lot of
That
stuff.
is a lot of stuff, right? And, to build, we forgot to mention, by the way.
Yes. Sorry, OpenAI, Azure OpenAI SDK. It's available in multiple languages. We've got Python, we've got .NET, we've got JavaScript, Java and Go. It's stable in multiple of those and in preview in Java and Go at the moment.
So there's a lot of stuff that we can pull together, and you actually need to bring multiple of these things together to build a single AI application. As a developer, you need your data, you need your services. Maybe you need some speech, maybe you need some function calling, maybe you need some assistance, different endpoints. You might need to integrate with other capabilities in Azure and your developer tools. And so that's where the Azure AI Foundry helps you as a developer bring all of these things together in one place that you can use to build generative AI applications. And one of the things that we're excited about that we announced today is the Azure AI Foundry SDK that lets you take all of the capabilities that we have in the Azure AI Foundry and bring them into your application and do everything that the Foundry can do programmatically from code. Some of the key things that the Foundry SDK offers is it allows you to leverage multiple of our popular models through a single coding interface, allowing you to switch between them very easily. It allows you to easily integrate AI capabilities into your application and develop faster with a simplified coding experience. So I'm just going to drop right into a demo and show what that looks like. So I'm going to start off here in the Azure AI Foundry. So in the Foundry, I can get started by creating a project. A project is something that allows me to organize all of these things into one place for my application. I can click the Create Project button. I can just provide a project name. I can provide a hub name to connect to my resources. I'm going to show what it looks like after I've created one of these projects. Inside the Foundry, I've got my project here. And inside the project, I've deployed a bunch of models. So I can go to Models and Endpoints. And I've deployed the GPT-4o model, the 4o mini model. So I can switch out these different models to see is 4o giving me better quality versus for how much I'm paying for the extra quality or performance. I also have a couple 5.3 models deployed and some embedding models, which will allow me to do vector search. The other capabilities we have here, we have in our AI services, a lot of the things that Rob was showing, speech, we got language translator, vision and document intelligence, and content safety. All of these are built into this one project, these capabilities that you can leverage. So if I want to jump to code, how do I connect to all these different things? Well, what I can do is I can just grab this project connection string, which is the one variable that I need to connect to my AI Foundry project from my code. So I've gone ahead and copied that code. And let's hop on over and play with some models from code. So I'm going to paste that project connection string here. And here I'm making a connection to the project using the AI project client.
So no keys.
No keys. There's
Yes.
no keys in my .env files. And as hard as I've tried to not leak my keys when I put them in my developer environment, it always happens somehow. So from this project, I can get a chat completions client. This is our unified model inferencing API that allows us to use all those models that I had showed you that I deployed into my project. We can get started with GPT-4o mini, and I'm just going to pop open the terminal and run this Python file, and we're going to see the output. I've made a kind of fun prompt here that says, you're a techno punk rocker from 2350, be cool but not too cool. And I asked it a question about taxes, and it's giving me some tax advice as a freelancer. So this is pretty fun. So, GPT-4o mini is a great model. Let's take a look at what a 5.3 model would output just by changing the model name. So I'll just come in here and say 5.3.5 mini -instruct. And I'm going to run this model. And this model, it runs a bit slower because this model is meant to be fine-tuned for specific scenarios.
Well, that was easy.
Yep, I'm just using a different model by changing one variable. Now we're seeing as it's streaming output, it's running a little bit slower in this case, but we can see what that response looks like, and we can compare it to what we got from the GPT-4o model. So we can then fine-tune this model if we want it to work specifically for this futuristic tax spot scenario. OK, so let's take a look at how do we have this model respond with context about our application, our users. So as I mentioned, it starts with data. And let's take a look at some data that we want to provide a chat experience over. So here's some product catalog information about Contoso Retail. And I want to take this data and I want to ingest it into an AI search index. So in my Foundry project, if I go into the Management Center, I've connected an Azure AI Search Index up to this project. That's all I need to do. And once I've connected it to the project, I can then get this search index through the project client using that one connection string. So I'll go ahead and run a Python script here to create a search index by ingesting this CSV file. And while that's running, I'll just pop open the code quickly here and show you at the top of the code, just like I got the chat client before from the project, I got a vector embeddings client, which will be used to embed the documents, and a search client, which allows me to connect to that search index. So just using that one project connection string, I can get access to those different capabilities. And I've got ahead and created that products index. Now, let me run a chat with products function, which will then allow this AI to answer questions from the documents in here. So I'm going to ask, what kind of tent would you recommend for 4 people? And while it's running, one of the cool things that, that this leverages is it uses a prompt template, this prompty file format, which allows you to specify, using a template engine, how you want to take the documents and insert them into that prompt. So here, you can see that there's a set of documents that are going to be retrieved from the search index and passed into the prompt. And we're just going to create a markdown document with those. And we can see the answer here being output in the terminal. It says, for a group of 4, I'd recommend the Trailmaster tent. Now, you can also, that's interesting, run this with tracing turned on. Sorry, I had the wrong terminal window. So built into this sample, if you do this -- enable telemetry, it's going to output a link to, it's going to log the tracing results to AI Studio so I can actually see what's happening when I'm running that code. And so here I get the trace of what happened, and I can now show you the different steps that were involved in answering that question. So I've got, first, I can see there's 2 LLM calls that were made. The first LLM call takes the question from the user with this sort of intent mapping prompt. And the user's question was, I need a new tent for 4 people. What would you recommend? And then the AI turned that into a search query of the best tents for 4 people. We then embedded the best tents for 4 people into a vector representation. And then we ran a search query to get the documents. And then the final prompt that we sent to the model was that one that we saw in the prompt template there, where it's taken those results and it's generated those documents, and it's passed it into the LLM along with the user's question, and there we got the answer back. So that tracing is really helpful because it helps you get an understanding, especially when there's all these complex interactions that are happening between your code and the models. You can quickly understand what the code is doing and potentially figure out where you went wrong. So this is fun and all, but I'm just playing with this app in the terminal, and it's not really giving me that user experience that I want to deliver. So how do we get this into an actual app where we can have a conversation rather than just a single prompt in and out? So if you head on over to the code page in the AI Foundry, you can see that we've provided you with a set of AI application templates that can help you get started quickly. There's 3 here that we're highlighting for different scenarios, but you can click the link to view the full AI app catalog. And we've got all sorts of different technologies that you can use for databases and vector search and programming languages with front ends. We've got some C#, Go, Java, JavaScript, Python, TypeScript. Developers use all sorts of different languages, and so these give everyone a different starting point that they can use. We're going to get started with the basic starter template here. And what we can do is we can install the Azure Developer CLI, which we can just run this command to init a new app, and it will clone this template down, set us up a new Git repo with all of the code that we need to provide a basic chat experience to our users. Now let's give it an environment name, and let's just take a look at what that code looks like. So here we have a basic application with a backend, some routes, and we've got some HTML. And what we can do is we can just take some of the code that we wrote, that custom rag code, and we can just pop it into the sample app. I've done that already over here. So that chat with products function, I just popped it into the routes of this sample app, and then we can just deploy the app. So here, if you look at the commands I ran in the terminal, I just used that project connection string to set an environment variable to say, hey, I want you to deploy an app that connects to that existing project I had created. And then I ran azd up, which built and provisioned the application. And so after that application was deployed, I just get a link to this external website that's been deployed. I get this nice chat UI, and I can say, what kind of tents do you have? Would you recommend? Let's try that one. And the assistant will come back and ask me with another question. So now I can actually answer that question and say, well, I have 4 people. And we can ask, where should I go to see stars? And because of the prompt that's provided, it'll tell us that it can't answer that question. All right. So that was a quick tour of how, thank you. How you as a developer can create a project, use a common inferencing API to try out different models, use Azure AI Search to ground your application's responses in your data, and then deploy applications to Azure using pre-built templates. Another thing that's coming soon that you'll be able to leverage next month is the Azure AI Agent Service, which allows you to unlock another level of intelligence in your applications, doing a lot of the things instead of having to write all that manual code that I wrote in this sample app. There's a few hundred lines of code in there that with the agent service, you can express that capability with just a few lines of code to create a vector store and run a chat function. And you can leverage additional tools like code interpreter, function calling to build these applications much more quickly. I think there was a talk on that in the room right before this, and I encourage you to definitely check that out. So I showed this application to my manager, Udi, who's actually sitting in the front row, and he said, great, can you ship it next month, right? Never happens as a developer, right? So I don't know, it worked for me. Did it work for you? I'm not sure. So this is where we're in that phase where we want to get our application to better and better quality, and we need to use a more rigorous approach to measuring and improving application quality. And so let me just drop into a quick demo on how we can do that using evaluation. Now, OK. So here in my code, I have this set of test questions. These are benchmark questions I'm going to use to evaluate my application. Just a whole bunch of different things that I'm going to ask and evaluate the outputs of my model on.
These are a lot like test cases, but for non-deterministic testing of prompts.
Exactly. And sorry, I got lost in the terminal scroll here. We can run that, and then we can see what the answers are to all those questions in here in the terminal. Let me just take a quick peek at the code. So inside the code, we've got this evaluate function, which I can use to run evaluation on that data set. And I can specify different evaluators that are been specially purpose-built by Microsoft and industry standards to evaluate and score how well the quality of those responses are based on these metrics. And so groundedness tells us how well is it using that context and answering factual information. And relevance tells us how relevant is that answer to the user's question. Now, I'm sure you're all thinking this terminal is not a great way to view those results, but after I run this Python script, it'll upload those results to AI Studio, where I can get a much richer way to go through and understand the performance of my application. And I got to say, I did a pretty poor job on this one. 1.62 out of 5 on relevance.
That's not great. Udi is not going to be happy.
It's not ready, Udi. Not ready. So what do we need to do to ship this next month? Well, let's take a look at all the inputs and outputs that are coming into the application. So here we can see for each of those test cases, what are the results that we're getting. And we can see that a lot of the answers to the question is just asking another question back, right? So I went into the application, and I went and changed my prompt. I noticed that inside the prompt, it was saying like, hey, if you're getting a vague question, ask for clarifying questions instead. But hey, this is AI. We can first respond with some suggestions from the documents and then answer the user's question. So I reran evaluation with this updated prompt, and I went back here, and I can actually compare 2 different runs with that original prompt and the updated prompt. And now I can go row by row and see the difference. Well, we can see that instead of just answering with a question, now we're getting a summary of different tents that are available, and then the follow-up question. So that's pretty cool. But why is it only a 3 out of 5 instead of a 2 out of 5? I think we did a lot better this time.
Yeah.
Well, this is where the reason comes in. The reason will tell you that, hey, this response accurately reflects the information, but the context is adding some unsupported details about waterproof ratings. What do you mean unsupported details? Well, it says the Skyview and Trailmaster tents both have waterproof materials and race lives for added protection. Is that not true? Well, if we look at the actual context information, we can see that inside of the context, this tent is water resistant. It's not waterproof. And so these are the kind of details that these finely tuned evaluators can pick up about your application. As a developer, I would totally miss this. And so this is how you can develop these applications at scale using AI.
That would take a lot longer to find if I was just combing through that.
I just wouldn't found it, to be honest.
Yeah.
All right, so that was a quick demo about evaluations. You can also run these evaluations in the cloud if you want to get it off your laptop so you can close the lid and get on the plane. And then you can also have human feedback in the loop to give thumbs up and thumbs down on those evaluation results. So, yeah.
Very nice.
So how do we improve further from here, Rob?
Well, fine-tuning might be a way to go. Let's take a look. All right, so you've heard about fine-tuning as well. I think there was a talk earlier today that had a lot of great details there. I'm going to touch on it just really briefly, but the idea is that you might start with using a very high-end model, but maybe that's not hitting your cost curve, and so maybe you're going to try to use a different model and or fine-tune it or distill it. Or maybe you started out with a more basic model and you need to actually add a lot more to it using this fine-tuning mechanism. And so either one of those directions you go, whether you start high and come down or you start low and you try to go up, optimizing via fine-tuning or distillation is a really important part. So one of the things that I'm going to show real quick here is that there are many different ways to do that. You saw earlier today in some of the presentations you can watch online. If you didn't, you can do that using some tool sets in a shell, or you can use the Azure AI Studio's fantastic capability, now called the Foundry Studio. Or we've also got capabilities built directly into VS Code. So it's, again, trying to meet you where you are, with the kind of development environment that you need to be able to do that. So let's say we get it all fine-tuned. Then what do you do?
My chat website was pretty cool, don't you think?
It was very cool, but wouldn't it be cooler if it was in Teams?
Now we're talking.
Now we're talking. All right. So in Satya's talk, you saw that we are describing the whole stack. We've got Copilot at the top. We've also got the whole AI stack. There's a way for you to plug capabilities in using these capabilities. And so again, if we switch back to, actually, let's go forward one more. So as you can see on this slide, this is that stack that we were talking about. And so you can take your intelligent agent and get it into various levels of the system any way you want. We're starting to run low on time. One thing I wanted to show you on the screen is if you did want to actually put it into Teams, the way you could do that is we also have an extension to help you with that. You got a problem? We got an extension. We got an SDK. We got the right thing for you in the right language. And so here you see there's a bunch of different capabilities. You can get to the documentation. You can view a bunch of samples. You can create the app. It asks you some questions. Maybe it's an agent, or maybe I want to create it differently. I want to create a custom engine agent, because yours was using chat protocol between your front end and your back end, right? So I could use one of these to then modify it to have the use of chat protocol. It also could be used over here in VS, Big VS itself, not just VS Code, for those of you that are still using VS for all your C# needs or other capabilities.
Most C# developers.
Which is most C# developers, that's right. So bunch of same kinds of samples, same kinds of capabilities. And I mentioned the chat protocol, and so there's a website here. You can go and learn more. There's a great set of SDK libraries for you to do that with as well.
All right, awesome. So after we've built our app, let's talk briefly about production. So on the road to production, one of the things that you're going to need is a lot of automation, right? So those evaluations that I showed you, I'm running locally. We can wire those up into GitHub Actions. And let me just quickly show how you can do that. So from that terminal where I ran azd init to create this app, I can also run, after I've pushed that Git repo to GitHub, I can run azd pipeline config. And it takes all these steps to set up credentials, environment variables, and everything so that I can run my code inside of GitHub Actions to automate, run evaluation as part of every code check-in to make sure I'm keeping that quality high, right?
I like that.
No more, it works on my box, but not yours. Does it work in CI/CD? So here, this is one of those evaluation actions. We've got an evaluation GitHub action where it can run all the evaluation on different inputs and outputs, and we can see those results here. And we can see different test scores for different test cases. And something new that I'm super excited about is once we pass the evaluation step, coming soon, we're going to have the ability to kick off an experiment after that evaluation step runs. So here I've got experiments integrated into my GitHub Actions. And let's just go through and look at this experiment analysis. So this is a case where we've tried out 2 different prompts. We're pushing a new prompt. We had a professional prompt, and we're pushing an adventurous prompt. And we can see that the experimentation action rolled that out to a treatment group of users. And we can see that there was some effect as a result. And you can look at all the different metrics that we have. And you can see that the average chat call duration increased as a result of this new prompt. So it took 40% longer to answer questions. It used almost 50% more tokens. But was it worth it? Well, we can look at from the thumbs up, thumb down from users that it didn't make any conclusive difference in the actual quality of the experience. So it cost more money, didn't seem to make a difference. Maybe we'll hold off on that prompt and keep the one that we have.
Good savings.
All right. So all this data is going to Azure Monitor, which means that you can also build production dashboards that give you a sense of what your evaluation scores look like over time, how much you're spending on tokens, and what models are being used. And so this is the kind of visibility you're going to need when building these kind of applications. And if you're interested in trying out the Azure AI Evaluation service, you can sign up for the private preview using that link and that QR code that's up on the screen. And with that, why don't you take us home, Rob?
All right, will do. So you've seen today a lot of different things. You've seen how you can go off and explore the Azure AI Foundry in all different variations, from using it in terminal windows, to VS Code, to VS itself, to the AI Studio, all over the place. It's there for you. There's a bunch of different SDKs, but the one we want you to also look at is this AI Foundry SDK, which is inclusive of our work on the Azure OpenAI SDKs as well. Use the one that's right for you. If you want to do multiple models, definitely pick out the inferencing SDK portion of the Foundry SDK. Got lots of great documentation. Some of it's integrated into various extensions. You can look on MS Learn. You can look through our sample repositories. We also have a lot of Learn courses for you to take advantage of. Just go up to MS Learn and check it out. We got a lot of different sessions, some of which were today, some of which are coming up. Just search online. I don't think you've noticed, but there's a couple talks about AI here at the conference this year. So it's not just these. It might be another 200 or so to take a look at.
All right. Thank you so much, everyone, for coming, and hope you all took something away from today's talk.